All right, we're going to be talking about syncing and sourcing as it relates to microcontrollers and other electronic devices. All right, let me go ahead and get rid of this. All right, so let's say that we have a microcontroller. And of course, being a microcontroller, we have inputs and we have outputs. With syncing and sourcing, we're looking primarily at the outputs. So let's take a look at this particular pin and say that we've configured it as an output. And what we want to do is connect up an LED. Well, we would need our current limiting resistor and we would need our LED. In this case, let's say that our anode end is facing the microcontroller and our cathode end is facing away from the microcontroller. Being the cathode, then we would need to connect that end to ground. So in this example, let me get my arrows on here indicating it is an LED. In this particular example, then, in order for this LED to light, I would need to provide a connection to the VDD or the V positive end of the power supply. That can be done internally in the microcontroller whenever we go high. So in this example, then, this LED will light whenever we make that connection, and then having a complete circuit to ground, this LED will light. So when it is configured in this fashion, this is referred to as sourcing because the microcontroller is providing the connection to the V positive. That means the other end of our device has to be connected to ground. Now we can also take a pin or a port, connect up an identical resistor and LED, but this time put the cathode end facing the microcontroller, and that would mean that the anode end would need to be connected to our positive end of our power supply. Let's say in this case positive 5 volts. In order for the LED to light in this circumstance, we would need the microcontroller to provide a connection to ground. Because we would have our connection to positive 5 volts, we'd be running through our LED, through our resistor. To complete the circuit, we would need to go to ground. So when it's configured in this fashion, this is referred to as syncing because the microcontroller is providing the connection to ground. In this top example, I said that in order for the LED to light, the port would have to go high because whenever an output goes high, the connection to our V positive is being made. The LED would go off whenever this port goes low. The opposite is true with syncing, that the output will only go on when the port is low because that's when the connection to ground is being made. And when we have that connection to ground, we have a complete circuit from the positive 5 volts to ground. When it goes high, that complete circuit no longer exists. You may ask, well, why would I want to use sourcing over syncing over sourcing? Well, with syncing, oftentimes the maximum amount of current that the microcontroller can sync is greater than it can source. So for example, this microcontroller might be able to sync 30 milliamps maximum. But in sourcing, only maybe 20 milliamps. So one of the main reasons then would be the amount of current. Now your logic is going to be completely opposite, but the amount of current that it can sync or source is going to be different. Now, this does not have to apply to only LEDs. It can apply to any other kind of device that we need to turn on and off. So let's say that I remove the LED out of there along with some of the text, and what I want to put in there instead is a motor. Assuming that my microcontroller could provide enough current to turn on this motor, so it would be a very small motor, I could connect it up in a sourcing kind of fashion. So one end of the motor would get connected to ground, the other end of the motor get connected to the microcontroller. The motor would go on whenever the port goes high. Now I could also take and turn on a motor through syncing. So let me get rid of the LED and the corresponding resistor. Let me put my motor in here. Same motor, but now we are connected with one end to the positive 5 volts, the other end to the microcontroller. This motor will now come on whenever the port goes low. So syncing the source can be applied to all kinds of output devices, in this case motors and LEDs.